Hello dear students. So today we are going to discuss about the solubility and solubility product of the sparingly soluble salts. Okay. So what is basically the sparingly soluble salts? So sparingly soluble salt means partially soluble salts. Means these are not completely the weak electrolyte, but those are not the strong electrolyte, but those are the moderate type of electrolyte. Okay, so which can dissolve in water to some extent, and there is existence of equilibrium between the undissociated molecules and the ions in the water. Okay, so such type of salts are called as sparingly soluble salts. So now what is solubility and what is solubility product of such type of salts, that we are going to see in this video. So first of all, what is solubility? The concentration of the solute in the saturated solution is called as solubility. Okay, solubility is nothing but the concentration of solute. Okay, it is the concentration of the solute in its saturated solution. In saturated solution is nothing but the solubility. It is nothing but the solubility, and this solubility is actually dependent upon the concentration of the solutes. Okay, in the saturated solution, what do you mean by saturated solution? It is a type of solution where no more solute molecules are likely to be dissolved in the solvent. See, the solvent is having some capacity to accommodate the solute molecules in it. है ना? It is having some type of capacity that how much amount of the solute will be soluble or will be dissolved in that solvent. So when that complete capacity or the complete capacity of that solvent is utilized by the solute molecule, that is nothing but the saturated solution. Means no more solute molecules can be added into the solvent, and those are cannot be dissolved further in the solvent. So that type of solvent or that type of solution is called as the saturated solution. It is having the highest concentration. So the concentration of the solute in the saturated solution is called as the solubility. Means it is actually the tendency of solute to undergo dissolution and to form a solution. Okay, this is nothing but the solubility. So there are number of electrolytes which are sparingly soluble in their aqueous solution. So examples of the sparingly soluble salts. The examples of sparingly soluble salts are very simple. Those are very typically AgX, means those are AgCl or AgBr, AgI, etc. Okay, AgCl, AgBr, AgI, and so on. And there are some more examples of this which are given in your textbook, but for convenience we are studying the sparingly soluble salts are nothing but the silver halides type. So halides are basically containing chloride, bromide, and iodide. So these are the some examples of the sparingly soluble salts, and these are sparingly soluble at room temperature. Okay, this is also a one more condition for the solubility, that the solution should be prepared at the room temperature. That solution or that water should not be heated to dissolve, because as we are increasing the temperature, the solubility will increase, we know that. So but we are preparing these solutions at room temperature. This is the very important condition. Now we will consider that how that AgCl as the example. We are considering AgCl as the example, and how AgCl is actually ionizes in the water, that we are going to see. So first of all we will write this reaction, that AgCl, it is in the solid form. Okay, So when it is converted into ions, so it will be Ag plus Cl minus, and these two are in the aqueous solution. Okay, so these are in the aqueous solution. So Ag plus and Cl minus, these are the ions which are prepared, and we know that as this is the sparingly soluble, means it is moderate type of electrolyte. So not the complete ionization is taking place, but some molecules are remaining as it is in the undissociated form. So Ag plus and Cl minus are basically formed. So we can write down the law, the equilibrium law. We can apply the equilibrium law, and now we can write down, this is equilibrium law. According to this, we can write down that as we are writing the concentration in this form, concentration of Ag plus into concentration of Cl minus divided by concentration of the reactant, that is the undissociated AgCl. We are writing in this way, but we can also write this in the form of the activity. We can say that the activity of silver ion, activity of chloride ion, and the activity of the undissociated solid silver chloride, we can also write it in the form of activity. So that activity is written as the small a, and small a we are considering for Ag plus, and multiplied by activity of Cl minus, okay, divided by activity of undissociated AgCl. So in this way we can also write down the equilibrium law, or this is nothing but the equilibrium constant. We very well know what is it, but for our convenience we are considering this activity of AgCl as the one. The activity of solid AgCl we are considering, that means AgCl is equal to 1. Therefore this law, this is the constant, equilibrium constant for sparingly soluble salt, hence we are writing Ksp. Okay, so it is nothing but the activity of Ag plus into activity of Cl minus, because we are considering this denominator as 1, hence this Ksp is activity of silver plus ions and the activity of Cl minus ions. So this Ksp is nothing but the solubility product of sparingly soluble salt AgCl. Okay, sparingly soluble salt AgCl, and this is constant at given temperature. This will not vary at the constant temperature. If we are keeping the temperature constant, this Ksp will remain the constant. Okay, so it is more convenient to express the molar concentration in terms of solubility product. So in this way we can also write it that Ksp is equal to concentration of Ag plus and the concentration of the Cl minus. So in this way also we can write down actually the solubility product. Okay, so now now we will consider another example of this. This AgCl is the first one example. Now secondly we are considering as Ag2Cl2. This is also a sparingly soluble salt, and it will dissociate in the water as Hg plus and Cl minus. Okay, as these two are having two ions, so we are getting 2 Hg plus and 2 Cl minus. These two ions are formed, but those are in the aqueous medium. Okay, so aqueous medium will contain now the undissociated Hg2Cl2 solid and 2 ions of Hg plus and 2 ions of the chloride one. So this is having such type of equilibrium is there. So now we can write down the equilibrium law. We can apply the equilibrium law in the similar way, and we can write down the value of KSP as, so that KSP we can also write it in this way, that Hg ion. So this coefficient will be present over here. So it is Hg plus square and it will be Cl minus square. So in this way we can write down the KSP value for the another sparingly soluble salt, which is mercury chloride, Hg2Cl2. So similarly we can write down the general equation in this way, that if we are having here in the case of AgCl, we are having only one atom of Ag and Cl. Hence the power is 1 over here, Hg plus and Cl minus. Here the dissociation of one molecule of Hg2Cl2, it is giving two ions. Hence that coefficient will become the power over here. So it will be Hg plus square and Cl minus square. So in general, if we want to write down for a salt, so we can write in general, okay, in general, suppose we are considering a salt like this. If the salt is in this way, that Bx and Ay, this is suppose the salt, and this is dissociated in this manner, so that X will become coefficient over here. So X times B plus in the aqueous solution always, plus Y times this A, which is minus in the aqueous. Okay, so such type of ions are produced. And now if we want to write down the value of KSP, the solubility product of this general type of salt, so we can write it in this way. So it will be B times plus X and then A minus Y. Y will become the power. Thus the solubility product of sparingly soluble salt in the aqueous solution can be defined as the product of the concentration of ions raised to the power equal to the number of times ions occurs in the equation representing the ionization of one molecule of salt. Okay, so it is nothing but the product of the ions which are produced when we are dissolving sparingly soluble salt into the water, and the number of the ions which are produced will become the power of this. So here the multiplication sign is present. So this is nothing but this solubility product of the sparingly soluble salt. Okay, so in this way we can write down the general equation for solubility product of the sparingly soluble salts. Now if we want to find out the amount of solubility product, for that we have to derive various types of equations for various types of salt, which are AB, AB2, A2B, AB3, A2B3 or B2A3. These are some types of the sparingly soluble salts which are there, and for those we are getting the different equation and the different derivation is there, and we are getting the final value of KSP in different forms. So all these 5 sparingly soluble salt and their derivation we will discuss in our next video. So let us stop here and do study all these things.